Okay, here's a sample of some of the questions from the thermodynamics essential questions activity that I had my students do. This first question here says, what does specific heat of a material tell you? And here's a reasonable answer here. The specific heat of a material determines its resistance to changes in temperature and transfer of energy. A higher specific heat means that the material is more resistant to change. You'll see that there are other answers that are similar, although not all exactly the same. Here's an interesting one. It tells you about the molecular structure of an object and how the application of heat changes the structure. It's a number that estimates how well the object is able to be affected by, hold, and release heat. So some very interesting responses there. The next question, how can we predict the equilibrium temperature when two materials are mixed? There's this sort of simplistic response here by using the equation that we learned. Okay, terrific. What about we can predict the equilibrium temperature by inputting the power from the materials that are being mixed and then setting them equal to 0. From there, we do simple algebra and solve for the final temperature or equilibrium. Pretty close, but maybe this one is best right here. We can predict the equilibrium temperature of two materials by multiplying mass, specific heat, and the change in final temperature from initial temperature for each material, then adding the two together. Using simple algebra, one can solve for the final temperature, and then the student tried to write the equation in there. So that was pretty complete and nicely done. Other questions: what are some differences between an idealized model and a more realistic model of a thermal system? How have we in this unit used the idea that energy is conserved, and how can one improve the reliability of data collected in thermal investigations? Those are all questions that I've had my students respond to, and I've got a really nice set of things to think about.